Presidio is our amazing sponsor for tonight. So let's give a big round of applause.
A little bit about Presidio. We're an IT company, so we're a traditional value-added reseller. We sell hardware and software, from the networks and the LANs and the WAN, Cisco, Dell, EMC, all of that. But we also work in the cloud, which is why I like to do these meetups, because we're meeting all these DevOps and coders, because that's an area of growth for us as far as a company as we're moving into, let's just say, moving contact center into the cloud or voice in the cloud, some of those things. So it's just nice to see people on the coding side, because that's usually the area we don't haven't talked to. We talk to closets with blinky lights. That's what we do. So trying to get outside the closets of the blinky lights and into the code. That's what we do. So thank you. Thanks for being here.
Without further ado, I'm going to hand this over to Jenn, our amazing talk for today.
Okay, hi. Welcome to my talk. First time giving it. Designing for testability. Yes. Cool. So who am I? I am Jennifer Moore. Mostly go by Jenn. I've been a software engineer for 9 years now professionally. I started out in software QA and then moved into QA automation and regular development for like 5 or 6 years, something like that. What I'm going to talk about is how to actually implement tests and testability into your projects, because I think everybody appreciates that testing is good for you and good for your projects, but then how do you actually do that when you get into your projects? It's hard, especially if it hasn't been done before. So basically, this is why testing is actually good for your project just on its own. The process of adding tests and having tests makes your projects more successful, on top of the value you get from actually executing those tests and ensuring that everything is, the way that you expected it to be and the way that it has been in the past. So the main, you keep making faces at me.
Sorry, I'm sorry.
Okay, so the main thing that I'm going to be talking about here is design patterns that will help make your applications more testable. And the main one, the most important one, if you take away nothing else from this test, is the repository pattern. Because what's probably making your software harder to test is that you need to connect it to a real database or a real network service or something before you can execute any tests, and that makes running those tests difficult and brittle and time-consuming. And the repository pattern helps you get rid of that dependency. So the repository pattern, and you may have heard this called a wrapper pattern in other points, but the basic idea is that you take your database client or your network client or your relational mapper client, whatever that is, however you're getting data, and you wrap it in a class that you control. And then that class will also provide custom access methods to, get one, get many, etc. And the idea here is that this repository, as code you control, it's also code that you can mock in your unit tests. And all of your access to the data will then go through that repository, and I have you can see what that looks like a little bit in practice. So you have the all of your but anyway, all of your controllers, as things are probably now, or commonly are now, are just talking directly to your database or whatever data source you have. The repository pattern kind of sits in between that. It manages all of the connections to your data source, and then it provides all of the data to the rest of your application. And the repository is mockable, and you can control it when you're running unit tests, and that means all of your, you can control what data you give to your the rest of the application, and create any arbitrary scenarios that you want to, and all of your tests can run independently of each other without having to worry about what order they run in or having to maintain a test database or anything like that. So that is the repository pattern, which, it's good for you. Dependency injection is the other like really big helpful design pattern that will make your applications more testable. And so with dependency injection, what this does is the way that applications will typically be built without it is that you, like all of your classes or objects or modules will know what their dependencies are in advance when you're building them, and then like do all of the work of getting it and initializing it and setting it up to run. And this makes those dependencies very tightly, or this makes your code very tightly coupled to those dependencies, and it makes testing like the code that you wrote independently of those things much more difficult to do. With dependency injection, you turn that around, and like your application code expects to be given those things from the outside. And so like your database connection or your graphics library or whatever it is that you're depending on is provided to it from an outside source. And like that, again, during testing means that you can give it a faked dependency that you can control, and you can provide your application code with any arbitrary data that you want to. And this makes it, again, much easier to test like error conditions, and all of your tests run independently of each other. You don't have to rely on like real network connections and real databases existing and being in a usable, predictable state, which is hard to do. Yeah. So design patterns. Design patterns are a big thing, and you can do these things incrementally. You can start implementing repositories for just one type of data or just one source of data. You can like onboard directly over time. So like it's not a huge lift. You don't have to completely re-architect your application in order to start getting advantages from these things. You can take one part of your application and make it more testable. Same with dependency injection. There are big dependency injection frameworks that make this that give you a lot of benefits on top of it, but the pattern itself can be implemented without any framework, which this is sort of what it looks like. See, as your starting state, you have your controllers or whatever responsible for doing a lot of setup for themselves and being very tightly coupled to all of those dependencies they have. With dependency injection, you remove that coupling. And with the framework, like the framework can make it much easier to manage those injections, especially like in testing versus actual production, or things like that. I mean, testing versus actual production is kind of the use case that I'm focused on right now, but there are other reasons that a dependency injection framework is beneficial. But it's not necessary, and you don't have to like jerry-rig a whole dependency injection framework into your existing application before you can start using this pattern. And you can use both of these design patterns together. So, and in that scenario, what you'll be doing is using dependency injection to inject your repositories into the rest of your application code. And this allows your repositories to basically do this. To have different repositories for different kinds of data and different data sources, and all of your controllers don't need to know anything at all about that. They just know that they're getting data from something and that it has methods to get and set, and etc. Cool. So, on top of design patterns, there are development practices that will make testing easier, and the real big one is to write the test first. And like really write the test first and then your application code. It's called test-driven development. You may have also, like there are a bunch of different flavors of it. You may have heard BDD or ATDD, which really these are just different styles that your tests will take. The important part is that you write your tests, and the tests will sort of define the parameters of your application code, and then you write application code to satisfy those tests. Yeah, I guess that's that basic idea. As an example of what that could look like, these are some pseudocode one-liners for how you do that. You would start with writing your API controller. The very first test you write, you decide it should respond to 200 response code. So you call response.send, and that test is satisfied. And now you want it to respond with an actual data object. And so you modify your response.send line to actually get that data object from somewhere, and then you again iterate to get a specific data object that your client is requesting, and then handle error conditions, and so on and so forth. But in every case, you really can write the test first. You can you can sort of scope out the parameters and the behavior that you're expecting from your controller, and then implement the behavior. And continuous integration. Continuous integration is a development process, and it's kind of like a whole team thing. It's not something that a single developer does. But the basic idea is that every change you make will be built and tested and deployed, and et cetera, and go through the whole development life cycle, so that you get more practice doing all of these things, and so that you don't have big surprises when it comes to deploy time, and you haven't done any deployments since the last time you did this, and you find out that that there's some difference between your development and production environments, or what have you. Basically, you do it more, and you do all of these things that where problems tend to crop up, doing the build, or running your tests, or trying to get the deployment to happen, or managing your passwords or whatever. Do it automatically and do it in all of your test environments. Do it in the dev environment, do it in the test environment, do it in production, and it all goes through the same pipeline. Yeah, continuous integration. So what we have. And finally, actually changing the design of your application to be more testable. This may sound like a big thing. It's not so big, and it will genuinely make your application more maintainable and more testable. So the kinds of changes you can make would be to, and here we're getting very theoretical and abstract, so what this looks like depends on what your application is, but being able to bypass different screens, or jump to specific points in the workflow, being able to inject data into your live application, being able to import and export your application state so that you can you can pass that around from environments to developer machines, and et cetera, and be able to reproduce behavior that you saw in some environment in a place where the developer can access it and understand what was happening. And I don't know, you can probably come up with more ideas for the kinds of changes you can make to your application in order to be more testable. But the goal here is to make testing easier, especially automated testing. So skipping parts of your application that are just informational and you don't need to test will make your higher level automated functional tests faster and more reliable, because you don't have to wait for screens to load and hope your timers are correct, etc. You can just jump straight to the checkout screen and start test that, and etc. And then beyond doing this stuff in development, because all that stuff is good to have, but you would want to turn it off when you actually get to production. When you actually get to production, though, you don't have to stop testing. And all of the things that you can do to test in production are things that you're probably already doing, or should be, like blocking, monitoring, tracing, etc. The real difference here is to think of it in terms of testing. So, write out logs and do monitoring, etc. To like with the goal of being able to figure out what's happening when unexpected things happen, and be able to discover things about your system when it's running in production, because when it's running in production is the part that actually really matters. All the things you do in development are great and they give you more confidence and more practice, but development is the part that makes you money. So collectively, all of these things are called application performance management. There are big APM tools that vendors will sell you. These are expensive. You, like as individual developers, you probably don't have any say in which ones you use, but you probably do have some ability to like actually use them. And so like make sure you're actually using them. Like write out logs so that your log aggregator can pick it up, and include the tracing modules in all of your programs so that you can get that tracing data, and et cetera. Like whatever your APM system provides you, make sure you're taking advantage of it, and then like do more, because there's always like you can always be better at these things, and like basically just look for ways that you can gain more information about your application when it's running in production. And that's it. That's my talk.
For the repository pattern, is this a wrapper that you have both in production and development?
Yeah, so this is code. It will be the same in dev and production. Like you could, as code, you could give it different behavior in dev and production. So you could go to, different data sources, or, like you can go to, in a test environment, for instance, you would probably like to get data from a source in memory rather than a database. And, like like there are different ways to handle that. You could have that built into the repository, or you could use dependency injection to inject a different repository for test than for data, or for production rather. But yeah, like it's the same in every environment. The same code.
I like the concept where you think about logging in terms of testing. Can you elaborate, like what does that mean in practice? Like do you write logs thinking about where your code would deviate from the expected?
So a little bit, but the bigger thing is that you can't really predict what you're going to want to see from your logs, and so the important thing is to maintain as much of the context as you possibly can. So log like the whole request that you get, or log like the entire exception, or etc. And like just try to maintain that context, and also build in mechanisms to let you correlate things with each other, like IDs or whatever that will let you correlate requests to database call to, etc.
You mentioned having setting up your logs so that you can use it as data to understand what's going wrong. Is that something that you got maybe like a couple examples of how you've been able to show that there's a consistent error in a particular part of the code because you were able to capture the log data?
Do I have an example of that?
You can make one up, though.
I don't think so. Like not offhand. But like that is a good question. And honestly, what I recommend is following Charity Makers on Twitter, because she talks about this and nothing else. So yeah, like if that kind of thing is of interest to you, like Charity Makers will be a great source of information for you.
Thanks. I'm wondering about handling alternate scenarios. Coming at this from I support women who code.
Okay.
I'm a product manager, so
Okay.
I'm coming at this from slightly from a completely But we are changing our development patterns. We are going more toward behavior-driven development. So I need to build more my team in doing that. So I'm curious about handling alternate scenarios. If team's writing tests first, how far down those rabbit trails do you go, and how does the rest of the Agile team support that effort? Can you kind of address that?
Yeah, so, I mean, like, how far you go with writing tests first, I mean, like, it's easy for me to stand up here and say always.
Right.
In practice, that's not true.
Exactly.
But, like, you should try to do more of it, and, like, when it gets to be hard, that's probably where you stop. But then, like, after the feature is written and you're, moving into more of a support dynamic, like, you definitely want to write a test that reproduces the bug you're fixing and then fix the bug. And, like, things like that. When behavior changes, you definitely want to write a test that asserts the new behavior and then make the change. Like, the other thing is make sure these tests are actually running. Like, having tests is great and they will benefit you, but you'll get even more benefit if the tests are running and you can, like, verify the behavior that they're trying to verify.
Well, that should be a pipeline setting, right?
Yeah, so, and that's, like, where continuous integration comes in, so that you don't have to trust anybody to run the test. Your build system does it for you.
I will say, as someone who's learning to do TDD now, the framework and testing first are good guardrails to make you change your habits.
Yes.
Changing habits is hard. And I think once you get better at TDD, it probably becomes more natural to write code that's easier to test. But by doing fully test first, is that only way to change these habits that we've built is just scrappy developers who can make things work.
Certainly a good way to change those habits, but it probably will encourage you to program in a more functional style, and functional programming is my preferred style.
If you have a team that's kind of resistant to want to do this, what would be maybe a good first step? Like, what would be some good low-hanging fruit that we'd be like, oh, we're not really doing test-driven development, we're just doing one little thing, we're gonna experiment.
Yeah, so I mean, like, if your team really doesn't want to do test-driven development, like, it's really hard to force on them. You can, I think code review is a good point to try and change behavior, though. So when you're doing code review, like, review the tests and ask to see the tests and expect that there are tests there. Like, if there aren't, or if the tests are not very good, like, focus on that. Why are there not any tests? Because the answer is probably that it was hard to test. And, like, in addition to not having good test coverage there, and that gives you less confidence, like, there's probably design problems that are making it hard to test. And, like, focusing on, like, valuing testing will encourage those design patterns to be reworked.
So we need to start doing code reviews.
If you're not doing code reviews yet, that is a great starting point.
Life on the edge.
What's that?
Life on the edge of that code review.
Or you can, just live on the edge. Do it.
I like this concept of even doing your integration tests before you start, because it's a little easier step in that right direction, because TDD on your unit tests can be a big change. But I think even just doing it on your integration tests, like these inputs to an API, these outputs, maybe you don't have unit tests first on all of the logic, but at least that's a good first step.
Yeah. And
I
actually
like that
written these,
idea.
imagine that they were unit tests, but it's all fake pseudocode. So, yeah, I mean, you can certainly, like, these tests will absolutely work at a, integration level of things. I just sort of wrote them in a BDD style, so focusing on behavior rather than specific details of the implementation.
anyways, it triggered that idea in my head.
How would you meet the objection that this is gonna add time? So any new behavior is awkward and unnatural at first because you're in a pattern. But how do you sell it as far as overcoming the objection of this is gonna double the time, going, all of a sudden the hours tracked goes up, et cetera.
So in practice, over time, like this will be better for your productivity. And like guys, you're just starting out, there will probably be a period of growing pains where things take longer. In order to get over that hump, I think the best strategy is to like really capture all of the costs that that you're paying for tech debt by not having these things. So, when you have the whole development team on the phone for hours for deployment, like that's expensive. And when you when you're constantly sending things back to development from QA because it was broken in testing and the developers didn't see that, like that makes things take longer. And so like all of these little things that you sort of think of as being just part of your process right now, like they don't have to be. And so capturing like all of those pieces and the cost of them, and then like stacking that up to the 1 or 2 or 3 sprints that it takes to get people onto to start changing habits and get people to work better and be better basically. Like that's where I would start. But also I'm a developer and usually the people I'm trying to convince are already on board, and what they need is permission.
I actually try to implement a huge push for TDD at our company and stuff. And one thing that I usually say when it comes to like that question in particular is all code that you write has technical debt. TDD is just a way for you to pay it off now instead of much later with interest.
Is this approach something that I don't know who asked the question, but if somebody else on the team really isn't interested in doing this, is this something that can be put into practice by specific members of a team without the entire team doing it? And if so, what would be the things to watch for to say, is it just quality report, how many bugs against this code set versus that code set?
I mean, yes and no. Like you can certainly have, one person on the team who's really driving it, but but the team is all, working together, doing the development together. And if they're not on the same page as to like what practices they're following and what design patterns they should be using, then, any good work that somebody does can be undone later by somebody coming back and doing things a less good way. So I mean, like a single developer who wants to just do things better can make some progress, but they're going to go wall pretty quick.
So it's really an entire team practice more than individual professional standard.
Yeah, I mean, like the team does need to agree to these things, and like it doesn't need to be a whole lump sum. Like the team can agree that they should, like take all of these scattered database calls and move them into a repository, and that's like that can be done over time, and that can be done. That's an easy pitch to the team, and then then once they're in a repository, now testing is much easier, and like configuring for different environments becomes easier and things like that, and like incremental improvements are absolutely still improvements.
What would you recommend for the hierarchy of needs of what should be implemented first? Like a repository that's changing your API, not calling SQLite on a data layer. So what are the first steps?
The first steps, I think, and this applies pretty universally, is to focus on the developer experience. So whatever is causing the most trouble for the development team is what should be fixed first. Because once the development team has that time and energy back, they can reinvest it into fixing more things.
Sorry, that just inspired another thought about what I've learned to like about TDDs is it lowers the stakes for getting things right the first time, because you know I'm going to be able to revisit this later without, like, when you get your head wrapped around a certain problem space and a certain product requirement, you want to think about everything and get it right, because you don't want to have to load all of that context back into your brain later. Whereas when you're doing TDD, you're not so worried about, or if you're at least having good test coverage, you're not so worried about getting it right, because you know if the product requirements change or if you miss something, you can jump back in, whether it's 2 days later or 2 months later, and change it with confidence. And I think that's a way where it helps us actually go faster.
Yeah, and like that is really the biggest advantage of having tests and having tests that you can trust is the confidence it gives you when you're programming, doing new development. Because like you can just run your tests and see that things that used to work continue to work. And you can use your tests as debugging tools. You can run your tests and set a breakpoint and see like what your code is actually doing in this scenario.
When the team is not using functional programming and you have to import that state to replicate the bug or the test, what methods would you use to export and import the state?
That's kind of a hard question. I don't know. Yeah, I mean, honestly,
Functional programming. Kafka.
Yeah, I mean, I think that really depends on what your application even is, and how it's written, and like whether you even have a single like whether your state is a single concept or like scattered throughout your whole application, and like it's complicated.
Yeah, we were playing around with Elmlang, which is a JavaScript framework, and it had this ability where you can just copy the entire state, and because it was just a transaction log, and it would then take you to that point in time, and you can then export it as JSON. Like, we thought that was a pretty cool idea, because then for troubleshooting bugs from the client, like we can just like copy their state and we see the exact same thing that they're seeing. Yeah, it's more function. Functional programming.
If your language or your framework supports that, like that is awesome. You should stick with that framework.
Sorry, I lost my train of thought for a second. So I was just curious, for anyone, at least maybe on the call right here, who maybe has never written a test before, what would be your advice as far as how to go about like sitting down and thinking about what tests to write and getting familiar with that like beginning process?
Or even like the mindset.
Yeah.
Like you said you just did it, like you're getting used to like breaking like the behavior, but like how do you
Get into
get ready?
No, it's. I mean, that's kind of a hard question.
Do you start with like the worst case scenario, like here's the thing that could go wrong that I really don't want to go wrong?
At least for us, we kind of do it the opposite. The first like test we write, like Jen was pointing out here, is like you write what you are expecting it to do. I'm gonna have it succeed, and when my test runs, it should register that it succeeds. And then you think of all the ways that it could fail and start testing for those kinds of things.
Yeah, I mean, like certainly starting with the behavior you expect is easier to think about. There's like also different test design tools that you can use. As a method, I like pairwise testing, which is basically just analyzing the various inputs that you have to your code or program or whatever it is that you're testing, and then breaking them out into pairs and testing each pair of them in isolation. combinations of, I don't know, like whatever, you have some sort of form. So all combinations of like signing up for the newsletter and like entering a phone number or whatever. Like, take those inputs and group them into pairs and then test vary those pairs and keep everything else constant. The theory here is that the vast majority of bugs that will ever occur in your software are the result of some interaction between two different states or data conditions. And so this gives you a structured way to build up good coverage of what you're testing without just doing it exhaustively, which is an enormous amount of testing for even small applications.
On our team, we do a lot of pair programming, and so for me, Cody has a strong TDD background, and so we rotate pairs, right? So Cody's kind of like a virus that spreads around the rotating pair with somebody else and rub off some of his TDD habits. But really, pairing for me was a good way to do it because it's so hard. It's like, well, I know how to get the problem done the way I know how to get it done, so you just go back and fall in. But pairing with somebody who's
I think pairing is a good way. I think probably even if they're not really testing oriented, because they'll still be sitting next to you asking what if X, and a lot of testing is thinking about what if X.
That's a good, especially because you're asking this is someone's first test ever, right? Take a class, find a lesson. There's YouTube videos and stuff. See how other people are doing it before you try and just jump in, because it will get really overwhelming really quickly, right? And so having examples that then get more complex, that kind of thing. I mean, I was a teacher, so I'll say that. But
background curriculum design.
So you can start off on something that's simpler and easier to grasp, and then as you practice, the same as practicing anything else, your brain will learn to think good, as we were all saying.
Something kind of add to what you were saying. It's when you practice, to practice, a good thing to do is go back and work on the basic programs you used to do when you started programming, Hello World and stuff like that, and start trying to do TDD with something like that, like a basic gradebook application or something like that. Try using TDD with that, and then slowly build that up, because those principles it'll make it a lot easier whenever you're coding something that you're already kind of familiar with to do TDD with.
Yeah. That's a good point. And I will also say that I came at this from starting in the QA team. And if that's you, great. If not, if you were lucky enough to just jump right into development, maybe just go hang out with your QA testers for a week.
Our friendly people.
It'll make you learn to be very thorough.
That's the truth.
Anything else?
What sort of thought to reusability would you bring to this practice? Okay, seems like that would be, I'm thinking of objections that here, and so that's one of the things that I'm wondering about. Sometimes this is so very specific that it's more like the pattern that becomes reusable than the actual code for test.
So for testing, yes. Reusability is not really a valuable feature in test code. So I gave another talk about this in the past. I went over that a little bit, but in your application code, you're probably striving for a dry pattern, don't repeat yourself. And that's great. Keep doing that in your application code. But in test code, it's more important that the test be like that what the test does and expects is obvious from looking at it. And so like having a bunch of like highly reusable modules where like everything is plugged in and it's just configuration basically in your test scripts, is a little bit counterproductive because you start looking at your test code and all of it is like test utility dot run the test with some input parameter, and like you don't know what you're even looking at. And if the test fails, like is that because something broke or is it because the requirements changed? Who knows?
And I would say that like to remember that like the tests are for us. Right? Like the tests need to be human readable. Like Jen was just saying, like I need to see, oh, this is the name of the test that failed. Let me go look at what it was trying to do. Is it the code that's failing or is it the test that's failing? You know, like so.
Although having said that, like tests for any given module or class or et cetera, like will have a lot of common set of code that they need to run through, and like every testing framework in existence will have like setup methods that let you centralize that. So that the code that's actually in your test function is just about the scenario that you're testing and not about like setting up your class to be runnable and testable.
I do want to add, I think to your point earlier, I just thought about this, when you were asking about how maybe to like, if you can start with one person doing it and it kind of spread around like his virus. I will say when I started at the company I work at now, like nobody wrote tests at all. And we had one team member come back on board and he always wrote tests. And from like the moment he started writing them, everyone else slowly started to pick it up around him, mostly because his examples are really clear to read and people have something to go off of. I don't know if that's true for most places or most scenarios, but
yeah, no, that's a really good point. Having like having a path to follow
exactly
does make it so much easier. And you know, I'm sure there are a lot of developers who aren't opposed to doing these things; they just don't know where to start. And if there's, you know, if somebody can get them started, then that's a lot easier. And then I guess also revisiting that point a little bit, if you have like just that one person on your team who is gung-ho about this and wants to do it, reward that. Praise them when they do that and make sure that everybody knows that this is good and that you value it, and you know, because like people want to do the things that will be good for them, good for the project. And so if you tell them that this is good for them in the project, then that changes the way they'll think about it.
How early in TDD do you bring in performance testing?
That is an interesting question. I don't really think of performance testing as being like a TDD concern.
Because for some applications, the performance of the system is one of the primary requirements. So even if it does everything correctly, technically the system fails if it can't do anything, if it can't do certain calculations within a certain amount of time.
Question like how do you do that, or more just
Or like how early in your development process do you build that system? Right? If you can't do performance testing right from the get-go because everything is, you can't really do performance testing just from local development.
right?
So what's the stage?
I think that like it depends on like on what is like required of it, like what things need to be more performant and stuff. Then you can do that. There are certain unit tests you can do where you just run the same. The test is like running the same thing like a million times, and then you try to make sure that it stays within a certain time frame or something like that, and then like have a timeout or something like that set at that point.
Yeah, I mean you certainly could integrate that kind of like benchmarking into your test suites, and you can do that as soon as you have something to benchmark. I don't know, but I mean like if you're working in a system where the performance of the system is one of the requirements, then treat it like any other requirement and start testing it now. Yeah, I mean, you know, if you have like real requirements about what the performance is, then write tests for them.
You can actually start
the results of your tests as soon as you start doing that, so that your code performs at this level. As a team, get together.
Yeah, and I mean, like, running those kinds of performance tests, you know, in a unit testing environment versus production is not really comparable, but you'll have tests there that are concerned with performance, and, like, it, you know, forces everyone to think about performance. You can do, I don't know, like, you might be able to integrate profiling or things like that, into your testing so that, you know, you can be, or especially like linting and static code analysis, so that you can catch whenever like connections are not being reused, for instance, and new ones are being opened, or you know, things like that. Yeah, I don't know, but it's a little bit of an odd question for me because I usually think of performance as being like a after the fact kind of thing. It's much, in most applications, it's much easier and more cost effective to just add more hardware to a system that's not performing well enough, and just keep doing that until adding hardware isn't effective anymore, and then figure out what's causing performance problems.
Yeah, we're at the data volumes where just scaling hardware isn't feasible.
Okay.
So it does come down to building the application correctly.
Okay, yeah. So I mean, if you've already done that and you're at, we can do it.